Now here we are going for a counter. Counters are of two types, synchronous and asynchronous counters. An asynchronous counter means the clock pulse of each flip-flop will be different for a asynchronous counter. And for a synchronous counter, the clock pulse for each flip-flop will be same. This is the basic difference. So for counters are used for counting purposes. Counters are used for counting purposes. It means that if I want to count some happenings in a real world, I can make sensors from the real world to the circuit, and the circuit can be made to count. So we know if counting is done using binary values. So if I want to count up to 4, I can use a count sequence like this. It is 0 0 0 1 1 0 1 1. So if I have circuits for counting like this, then if I arrange a sensor in such a way that an input comes to the circuit, and during each input the circuit counts. So this is a real world application of a counter. If I want to count the number of persons entering to a seminar hall, then we can have a sensor at the door, and during each time when the light beam is cut, we can have a voltage variation given to the counter inputs. Okay, so a flip-flop is a 1-bit counter, and if you want to count 2 bits like this, then we need 2 flip-flops. If I need a 3-bit counter, then I need 3 flip-flops, and if I need n-bit counter, I need n flip-flops. So I am drawing a 2-bit counter now. So a 2-bit counter means it can count from 0 0 to 1 1. So 2-bit means it has 2 raised to 2 states equal to 4. If I have 3 bits, then 0 0 0 up to 1 1 1 equal to 2 raised to 3 combinations is equal to 8 different states. Okay, so for each bit I am using a JK flip-flop. And the J and K are shorted and is connected to a high voltage, means J and K are made 1. So this flip-flop is a toggle flip-flop. This works in toggle mode, and I am giving a clock pulse here. I am giving a positive edge to gate clock pulse here. See LK. I am giving a positive edge to gate clock pulse here, and here we have Q and Q bar. So if I am applying this Q bar to this JK, and for the second JK clock input, I am connecting this Q bar to the clock input of the second JK, and this is labeled as flip-flop 0 and flip-flop 1. And this circuit can be used as a 2-bit counter. And we can see that this is clock and this is the second clock. The first clock and the second clock are different. First clock is applied directly, second clock is from the output of the first flip-flop, and so the clocks are different, and so both the flip-flops triggers at different times, and so we call this as a asynchronous counter. This is 2-bit asynchronous counter. Okay. Since the clock is different, we call it as asynchronous counters. Okay. Now we will try to form the count sequence, and I am drawing a clock pulse here. This is the basic input. We have only one input from the external, that is clock, and this circuit counts each clock pulses. So I am drawing a clock pulse here. Okay. And since this is a positive edge triggered, this circuit triggers at the positive edge only. This counter triggers or reacts only at the positive edge only. And I am drawing this Q here. Q means Q0 here, the output of the first flip-flop. And assume that it was zero at the initial state. And so when the clock is applied, it toggles. And during the next clock pulse, it again toggles. During next triggering edge, it toggles. During next, it toggles. So during the positive edge only, it toggles. Now I am using the Q bar as the clock of the second JK. So I am drawing this Q0 bar also. So when it is Q is 0, Q bar will be 1, and so it is just opposite. Okay. And this Q bar is the clock pulse of the JK. So it is also positive edge triggered. This JK is positive edge triggered. So this JK responds at the positive edge. This JK responds at the positive edge only. Okay. Now we can draw the output of the Q1 now. What will be Q1? If it was 0 previously, then it becomes 1 at the positive edge. Then it toggles at the next edge. Then again toggles at the positive edge and continues. Okay. So this was the clock pulse. And if I observe this, during the first clock pulse, Q0 is 1, Q1 is 0. So Q1 is the MSB and Q0 is the LSB. So Q1 is the MSB, flip flop 1. Q1 is the MSB, Q0 is the LSB. So circuit, comparative circuit, first one is LSB, second is MSB. So this is 1 0. Previously it was 0 0. The assumption was 0 0. Now it is Q0 is 1, so it is 0 1. And the second clock pulse we can see it is Q0 is 0, Q1 is 1. So this is now like this. And at the third clock pulse we can see that it is both are 1 1. So it is 1 1. And at the fourth pulse Q0 is 0, Q1 is 0, again 0 0. At the fifth pulse is 1 and 0, so it is 1 and 0, and so it continues like this 1 0 1 1 0 0 etc. So this is a 2-bit counter. After the 4 states 0 0 0 1 1 0 1 1, it again continues this 4 states 0 0 0 1 1 0 1 1. So since we have only 2 bits, the counter counts, resets, again counts and counts. So for each clock pulse, the counter increments. So this is a up counter because it counts 0 0. So 2-bit up counter of synchronous time. Okay. So this is the circuit for the 2-bit up counter asynchronous time. Okay. If I am using this input of the second pulse from Q, Then by observing and drawing circuits like this, we can verify that it is a down counter. So positive edge ആയിട്ടുള്ള flip flopനകത്ത് if I am giving connection from Q to clock input of second JK, it works as a down counter. ആദ്യം കണ്ടത് അപ്പ് കൗണ്ടർ ആയിരുന്നു. ഇതിപ്പോൾ എന്താ പറഞ്ഞത്, if I am changing the connection from Q bar to Q, Qനകത്ത് കൊടുത്താൽ it becomes a down counter. Also we can change the triggering also, and this down counter, now it is down counter, and if I change this as a negative edge trigger type, then it becomes a up counter. So negative edge triggered connection from Q is a up counter. Negative edge triggered connection from Q is up counter. Okay, that is negative edge triggered connection from Q up counter. Negative edge triggered connection from Q bar, it is down counter, negative edge triggered. Positive edge connection from Q is up counter. Sorry, Q bar. Then positive edge connection from Q, it is down counter. Okay. So these are the 4 types of connections. So study only one thing, and now you can use this relation for changing the different states. So down counter counts like this: 1 1 1 0 0 1 0 0. It repeats. So these are 2-bit asynchronous type counters. So watch the video again and again to understand this concept.